Okay, so one last problem on arc length. Let's find the length of the curve to the graph of f of x is equal to the ln of secant x on the interval 0 less than equal to x less than or equal to pi over 4. So we know the formula. It involves the derivative of the function, so that's the first thing we're going to do. The derivative of the function ln of secant x is, well, the ln of u is 1 over u prime. So 1 over secant times secant prime by chain rule. So that's 1 over secant times secant tangent. The secants cancel out, and we only have tangent. So the length of the curve is actually equal to, general formula, the integral from a to b of the root of 1 plus f prime of x squared dx. We just figured out that our f prime was actually tangent. So the inside of the root is 1 plus tangent squared. The bounds are 0 to pi over 4, and it's a dx integral. But of course, we'll remember the formula that 1 plus tan squared is, yes, you got right, secant squared. So the square root of secant squared is nice. That's the integral of secant itself. That is not a nice integral. We have to kind of know it by heart. And if you do, then you know that the integral of secant is ln of secant plus tangent. Bounds, pi over 4 to 0. So FTC part 2, plug in the pi over 4, plug in the 0. The secant of pi over 4, well, it's 1 over the cosine of pi over 4, which is root 2 over 2. So we flip that up. 2 over root 2 simplifies to be just root 2. The tangent of pi over 4 is 1. The secant of 0 is 1 over the cosine of 0 is 1. And the tangent of 0 is 0. So when all is said and done, we are simply left with the ln of root 2 plus 1, or in simple terms, 0.88 units. That's it. Thank you.